All right, guys, we're back. Yesterday's video was a little longer than I wanted to, but sorry about that. I had to kind of get some basics out. So today's not going to be as long, just a couple of little things. Okay, so let's just recap real quick about waves. Real quick. Waves. Recap, right? So unfortunately, right, difficult for us to kind of visualize these things here, right, together on YouTube video on a white piece of paper, but there's how we represent a wave, right? It's kind of this abstract thing where think of it as like the water, right, in that swimming pool or fish tank. Here's my equilibrium position, and it's wiggling up and down during time. Okay. Now, a couple of things. One thing that I didn't mention yesterday, which I need to mention today. What about the energy here? What makes one wave, have more energy than another? Well, I gave you a couple of things yesterday, right? We had a wavelength, so here would be a wavelength. Not to mention, that's one wavelength, right? Crest to crest, I can do this. I can make this out here, right? This is also going to be a wavelength, right? Not to mention, this also would be a wavelength, right? So there's also a wavelength, right? What did I call this section right here, or this section right here? Well, I call that an amplitude, right? What would make one wave have, more energy than another? Let's see if I can draw this red wave, right? I'm going to do the best I can, right? There's a red wave, see? Now, if you look at the red wave, right, compared to the black guy, what's the same? Well, it looks like the wavelength is exactly the same. But what did I change? Well, I changed the amplitude. Well, think of the beach, right? You know, if you want to go surfing or body surfing or play in the water, right? Depending on, how you feel, you might want big waves or you might want small waves, right? So what is related to energy? Well, if you said amplitude, you are correct. Okay, so that kind of should have been mentioned yesterday, which unfortunately I kind of neglected, right? All right, so now let's go back to waves again, and let's talk about another very, very important characteristic of a wave, right? So let me draw, right, a wave again, right, and how we kind of look at a wave, right? And by the way, I'm always drawing transverse waves, right? Because they're just easier to represent on a piece of paper. That doesn't mean that you might not be looking at a longitudinal, right? Okay. So let's take a look, right? Remember, here's that surface, right? And here's the wave, which is going to wiggle back and forth. So let's suppose that I tell you that the wave started here, or I should say the point on the wave started here. It went down, back up, and then back down again. Well, what happened there? Well, what we would say is that actually that wave, or that point on the wave, up, down, up, completed one cycle, right? Up, down, up, and back. So it would keep going, by the way, up, down, right? Wiggling back and forth, back and forth, back and forth. Right, so what we actually have a way to describe that. This is called the frequency of oscillation, really, right? Right, and it's F. So let me define what it is. What is a frequency? It is the number of cycles a wave completes per, remember per, we're going to divide second, right? Let me write that out. Seconds, right? So it is the number of cycles a wave complete per second. So let's for argument's sake, let's say here's my point on this wave. It goes from my equilibrium position, down, up, one, down, up, back to my original, down, up. Let's just say, make argument's sake, say that it completes this cycle. I'm just going to say one cycle in 1 second. Well, what's the frequency? Well, by definition, the frequency is the number of cycles per second. So in this particular case, how would I say that, right? I would say so this frequency in this made-up case is going to be how many cycles per second. And what did we say? 1 cycle in 1 second. So in this particular case, 1 divided by 1 is 1. Now let's take a look at the units. They're a little strange. It's really cycles per second. But the cycles, we don't really want to put that in there. So we're going to say over, this is 1 cycle per second. So my unit is really a cycle per second, which we leave out. So it's just 1 over seconds. We don't really like that. So we're going to have another kind of unit. And a cycle per second is called hertz. All right? So in this particular case, since this wave that I just made up completed 1 cycle, meaning it's back to its original position in 1 second, 1 hertz. Well, suppose that, and by the way, I say it's wiggling back and forth, but actually this is not a very big wiggle, right? So the frequency is kind of low. But let's just say that I take this wave, right, a different wave, and it goes here, right, back, down, and it comes back again. So we went 1, 2. So let's just say that it went through 2 cycles per second. Well, what would be the frequency of a wave that has 2 cycles per second? So frequency, 2 cycles per second. Really, it is 2 cycles per second. We're going to rewrite it as 2 hertz, right? So what is the frequency, right? Number of cycles per second, right? And we kind of represent that by hertz. Okay, it's not wrong to say cycles per second, but we can say hertz as well. Now let me tell you another way to look at this. This way I think is visually a little bit easier. Now I'm going to have to draw something out, and it might not be perfect, but I'm going to do the best job that I can. So let's just do this. So there's 1 wave, 2, 3. So let's call this wave number 1. Right? And I'm going to draw another wave, right? Right underneath it, right? Right underneath it. Right? And this one I have to be a little bit more careful. That one snuck in there. Not terrible, but not good either. And there's another one, right? So 1, 2, good, right? And let's call this wave number 2. And let's suppose that I take my map of my eyeball, right? There's the map of my eyeball, right? And it's looking at this point, right? And let's just say, right, that at all times, right, let's call this A, point A, B, C, and D. And the time, right, and by the way, everything is moving to the right. So think of it as the wave is moving continually to the right. And let's just say, right, that it's always, right, going to be 1 second for this guy to get there. Well, let's not say that. Let's just say at the same exact time that B gets to this new spot, this B over here also gets to this spot. So let's see, is there a relationship? Well, what is this? Well, this here is a wavelength, right? And if this is a wavelength, it looks like this wave, when B got here, right, went through how many wavelengths? Well, 1 wavelength went through there, right? So what do I have here? In this particular case, right, what's my frequency? Well, my frequency is going to be the number, right, of waves that pass through this point per second, right? So let's say, I think I should say that to A to B, it took 1 second for that wave to get there. I think we could say that, right? So how many waves went from here to here? Or I really should say, how many waves passed point A? Well, it looks like 1 wave, right? 1 wavelength, right, went through there. So that's 1 hertz. All right, if that's the case, what was my wavelength here? Well, looks like I went through, remember the wavelength? I'm going to have a wavelength of 1, and we're going to say it's a meter. Okay? So now let's take a look at what's the difference between wave 1 and wave 2. Well, let's see. What just happened here? Well, how many waves, right? How many waves moved through, right, this person, right? How many? So what's the frequency? Well, it looks like I had 1 wavelength, 2 wavelengths per second. So this guy here had what? 2 hertz. Well, if that's the case, I got to think here for a second. What I'm really trying to get at, by the way, is I want to tell, hey, is there a relationship between frequency and wavelength? Well, let's take a look over here. What happened to my frequency in this particular case? Well, I went from 1 hertz to what? 2 hertz. How many wavelengths went through there? Got to be careful here for a second. How many wavelengths? Well, there's a wavelength. And there's another, what, wavelength? Well, if that's the case, I had 2 wavelengths go through, right? Let's make this also 1 meter, right? So what just happened? I should say I had 2 complete waves. I really should say I have 2 complete waves passing this point. So what just happened to my wavelength? It must have went down. So what's my wavelength in this particular case? Has to be a 1/2 meter. Why is it 1/2 meter? Because I'm going to say this is in fact 1 meter. If I have 1 meter and I have 2 waves going through there, right? 1 meter, 2 waves, 1/2 meter plus a 1/2 meter is 1 meter. So look what just happened here. What is my relationship between frequency and wavelength? Well, I happen to be indirect. Okay? So I need to kind of come up with an equation that kind of states something like this. And I'm going to just flat out tell it to you, and I just kind of have to just say it. If these medium, by the way, medium is what the wave's going to travel through, like air, water, space, it doesn't really matter, right? Right? The speed of the wave, once it's in a certain medium, never changes. So what that tells me is, right, that the frequency, right, and wavelength are indirectly related, right? So I have a relationship, right, between frequency and wavelength. So the frequency times the wavelength is going to give me the speed, right, of a wave in that particular medium. Is that okay? So here is our first equation in our waves unit, right? Waves, right? So let me do a couple of little examples for you, okay? Real quickly, right, just to kind of see how things are going to go. It's really not terrible, okay? So suppose, right, I had a flashlight. There's a flashlight, right? I'm going to turn that guy on, and I'm going to get a wave of light kind of coming out of it. Let's give you some information. Let's say that the frequency of oscillation is 5.2 times 10 to the 14th hertz. And I'm giving you real numbers here. These are the actual real numbers of some light waves, which we'll get to much later on, right? All right, well, what is the wavelength in this particular case? Well, there's some stuff that I have to give you first. Okay, so to do this, answer this question, I want to give you some velocity of some common waves. And to do that, I'm going to take you to the reference table, right? So here is our reference table, right? And I'm going to give you some speeds of some common waves that we're going to be dealing with in this class. First, speed of light in a vacuum, 3 times 10 to the 8th meters per second. Now, hopefully you recognize that that is a ridiculously big number. And I'm going to geek out a little bit here, but I have to tell you, that's just the fastest anything can travel. It is what I like to call a cosmic speed limit. Nothing can travel faster than that number. Talk about more when we get to the next unit in light. What's another common speed? Well, how about the speed of sound? Right, now don't be confused. In the reference table, it's called STP, standard temperature and pressure. Not to be worried, not for you to worry about. So, I mean, if you get a problem, they have to tell you it's standard STP. I don't want you to be confused. It's just they're converting it to standard temperature and pressure. And how fast does it go? Well, it's about 330 meters per second, which is still pretty fast. So, I just want to tell you, if you get problems with light and sound, They're not going to give you those speeds. You're going to have to look those up on the reference table, okay? So they're on the front page and right there, okay? So let's go back to my light, my wavelength of a flashlight. So my velocity here is going to be 3 times 10 to the 8th meters per second. If you did notice on the reference table, by the way, the speed of light, a little confusing, we just call it c, and that's just, it's just another way that we designate the speed of light. It is a velocity. In this particular case, I can just use v. So what is the wavelength of this particular light? Well, from my reference table, velocity is equal to frequency times wavelength. So how fast does light travel? 3 times 10 to the 8th meters per second. What's the frequency of the light? 5.2 times 10 to the 14th hertz. What's my wavelength? Well, I did this already, right? So I'm going to tell you that the wavelength is going to be 5.7 times 10 to the minus 7 meters, right? Which, by the way, is pretty small, but that is typical, right? Next, let's do a sound wave, right? Let's do sound. Now, I'm going to do something a little bit different. I'm going to do sonar. Now, sonar is a sound wave in water, right? Okay? Now, they don't have that on the reference table, but I'm going to have to give it to you right here. So let's just say that the velocity of a sonar wave, 2 times 10 to the 3 meters per second. Let's say that the frequency of this wave underwater is 4 times 10 to the 3 hertz. Well, what's the wavelength of this particular wave? Velocity is equal to frequency times wavelength. So what do I have? 2 times 10 to the 3 meters per second, 4 times 10 to the 3 hertz times the wavelength. And I did this on purpose, so when I divide, I'm going to get 0.5 meters. So there's two really simple, right, applications of waves, right? Now, I asked you guys to look at, right, a little video. Now, let me try to explain to you what's happening here. This is Resonance. It's rather unfortunate. I have a lot of great demos that can be done in class, but unfortunately, I just can't do them here. So we have to do the best that we can. So what was going on there? First of all, let me talk about resonance and what it is, right? All right, you saw the man jump up and down in the pool, right? So what was happening? As he was jumping up and down in the pool, you noticed, hopefully, that the amplitude of those waves got bigger and bigger and bigger. So what is resonance? Well, it's a phenomenon when what happens is when we add energy at the natural frequency, right? The amplitude of oscillation will increase, right? So, just to let you know, all objects have what we call a natural frequency, swing set, a lot of other things, right? I can make them vibrate, right? And the amplitude of vibration is going to increase. So let's take a look at what happened, right? So the man was in the pool. There's the pool, right? Here is my equilibrium position. What did he do? He started to jump up and down in the pool. Okay, so I'm going to draw something. Here is my equilibrium position. And what he started to do is he started to jump up and down. So I'm going to do the best that I can. I'm going to draw what the wave kind of looked like, right? So as he pushed the water down, right, he's causing a wave inside the water, right? And it's propagating out both to the right and both to the left. Now, obviously it doesn't escape the pool, right? But this wave goes this way, and this part of the wave goes that way. And what does he do again? So when he gets down to the bottom, he's going to jump up, right? So what's going to happen is you're going to get, well, let's see if I can do it. You're going to get the red wave. Now, these are the same exact water, just doing what? Wiggling, right? Back and forth. He's pushing down. He's going to jump up. And when he gets to right here, he's going to push down again. So this might have a frequency, right? Down, up, push down. As I push down, the next time I push down, this wave, right, the crest, or should I say the trough, might be a little bit lower. It's going to go up, down, and it gets here, push down again. It might get a little bit lower, which means this guy's going to get a little bit higher, this guy's going to get a little bit higher, and this guy's going to get a little bit higher. So what he's doing is he's adding energy at the natural frequency which this water wants to oscillate back and forth, and he's causing the frequency, or I should say the amplitude of oscillation to increase. So this is resonance, right? Well, that's it for today. I'll send some more stuff over to Test Wizard, and I'll see you tomorrow.